Hello. This is a video to solve a few problems, scheduling problems using first come first serve. As we know, first come first serve is non-preemptive, which means that assuming all processes are pure CPU, so none of them is going to be requesting I/O. This means that the process will not be interrupted and it will continue until it's done. And this is the assumption here, that all of them are pure CPU. Here is the table that represents the different processes with different arrivals and different bursts. Let's schedule that. As you can see here, the very first arrival is at time 5. That's for process P1. So this means that for the time from 0 to 5 here, that's idle. The processor is idle, and of course we don't have remaining for the idle. So starting from time 0 all the way to 5, the processor is idle. Then we have here the arrival of P1 from time 5, and the burst is 5. Again, it's non-preemptive, so P1 is going to be starting from 5 all the way to 10 because the burst is 5. So from 5 to 10. And of course, the remaining is 0 because nothing will interrupt this process, so it will continue until it's done. So from 5 to 10, you have here P1, the execution of P1, and P1 is done. Now, as you can see, the arrival of P2 is 14. So this means that starting from 10 to 14, again, the processor is idle because there is nothing to process. And there is no remaining time for this one. And then at time 14, you have here the arrival of P2. Let's draw the idle here. And then P2 goes from 14 with a burst of 7. 14 with a burst of 7. So it's going to work all the way until 21. 14 plus 7, that's 21, right? And there's no remaining, so the remaining is 0, right? So this is going to work from 14 all the way to 21. That's P2, and P2 is done. Then P3. P3 arrives at time 18, as you can see. But of course, the CPU was busy from 14 to 21. So the time of the arrival of 18, the CPU wasn't available. So P3 had to wait until the CPU is available. CPU is available at time 21. So P3 will start processing from 21, not 18, the arrival, so 21. And P3 has a burst of 4, so it's going to be from 21 all the way to 25. That's the 4. And the remaining time again is 0 because it's non-preemptive. Here it is. This is P3, and P3 is done. Now, you have P4. The arrival time of P4 again is 20. But the CPU was very busy processing P2 and P3, right? So P4 now is going to be starting at time 25. That's when the CPU is available. And it has a burst of 10, so it's going to be working from 25 all the way to 35 with no remaining time. So this is going to be from 25 all the way to 35. That's P4, correct? Yeah. 25 arrives at time P5 arrives at time 25. P5 is gonna start working at time 35. That's when the CPU is available. P5 has a burst of 5, so it's gonna be working until 40 with the remaining time of 0. That's P5 here. P5 done. And then P6 has a burst of 2. So P6 starts working at 40 and it finishes at 42. Here it is. P6. Okay. Let's do a quick sanity check. Sigma of bursts equals, I have here the 5 plus 7 plus 4 plus 10 plus 5 plus 2. That would give you, here is a 12, 16, 26, 33. That's the sigma of all the bursts. Don't forget that we have two idles. Let's do the sigma of idles. This is going to be 5 plus, here is the 5 from 0 to 5, and here is an idle from 10 to 14. So this is going to be a 9. So the total time is going to be 13 plus 9, that would be 42, which is correct. Okay, that doesn't 100% guarantee that you solved it correctly. Maybe you have done two mistakes that, you know, get the result correct, but, you know, having the same values here would be a sign that there is a high chance that you are in the right direction. Now that we have done this, we can calculate the waiting times. So waiting time 1 for process number 1, waiting time 2, waiting time 3, waiting time 4, waiting time 5, and waiting time 6. Okay, so waiting time 5, as you know, this is non-preemptive. You can actually use one of two equations for the waiting time. It could actually be finish minus arrival minus burst. But because this is non-preemptive, you can also use start minus arrival. Any one of them is correct. All right, so the waiting time of the first one, it started at time 5, arrived at time 5, so this is going to be a 0. Process 2 arrived at time 14, and it started at time 14 as well, so it's going to be 14 minus 14, that would be a 0. Process 3 arrived at time 18 and it started at 21, so it's going to be 21 minus 18, this is going to be a 3. Process 4 arrived at time 20 but started 25, so this is going to be 25 minus 20, this is going to be a 5. W5 or process 5 arrived at 25 and it started at 35, so this is going to be 35, which is the start time, minus 25, that's the arrival time, would be a 10. P6 arrived at 26 and started at 40, so this is going to be a 40 minus 26, this would be 14. The average waiting time, of course, as we know, that would be the sum divided by the count. So 3 plus 5 plus 10 plus 14 divided by 6. They are 6, correct? So that would be 8, 18, 28, 32 divided by a 6, which is gonna be 5.333. Yeah. Okay, so that would be the average waiting time. Of course, I don't need to calculate the average response time because it's going to be exactly the same as this is non-preemptive. Okay. All right. You can also calculate now the turnaround time. The turnaround time for every process is going to be the finish minus the arrival. So as an example, for P1, it finished at time 10 and it arrived at time 5, so it's going to be a 5. For P2, it finished at time 21, it arrived at time 14, so this is going to be a 7. For P3, it finished at time 25 and it arrived at time 18, so that would be a 7, and so on. And then you sum them, divide by 6, that would be the average turnaround time. Now let's calculate the throughput. Equals number of processes, we have 6, divided by the total time, that would be 42, which is going to be 1 divided by 7. How about the CPU utilization? CPU utilization is sigma burst divided by the total time. We already calculated the burst before, so that would be 33 divided by 42. Okay, maybe, I don't know, around 76 point something. Okay, almost 77%. Okay, so that's how you solve this problem. Of course, I did not solve here the response time and the turnaround time. As you know, the turnaround time again is the finish minus the arrival. You calculate it for every process and then you get the average. The response time in this case is going to be exactly the same as the waiting time because it is non-preemptive scheduling. You have here another problem. Let's solve the other problem here. So I have here P1 arrived at time 4. So I have here an idle state from 0 to 4. And then process 1 arrived with 4. And the burst is 5, so it's going to finish at 9 with no remaining time because this is non-preemptive. Again, it's first come, first serve. P3 arrived at time, P2 arrived at time 6, and the burst is 2. So P2 here is going to start at 9 and finish at 11 because the burst is 2 and there's no remaining time. Right, P3 will arrive at time 10. So here it is, P3 arrives at time, arrives at time 10 and is going to start at time 11. That's when the processor is idle. And then with a burst of 3, so this is going to be 14. Here it is. And the remaining is 0. You have here P4. Arrives at time 15 and the processor is idle at 14, so you have an idle state from 14 to 15 here. Then at time 15 P4 arrives. All right, here 15 is gonna work all the way to 16 with no remaining time because the burst is 1. And then you have another idle state from 16 to 20 here because the next arrival is at time 20. So P5 arrives at time 20. It has a burst of 4, so it's going to finish at 24 here, and the remaining time is 0. And then you have the coming arrival is at time 30, so you have another idle state from 24 all the way to 30, and then you have P6 that arrives at time 30 and it will finish at time 32, 0. Okay, I did not do the timeline that has a, like how I did it for the last problem. You can directly do it in this table. So having said that, you can now calculate the waiting time of process 1. I'll call it W1. W1, because this is non-preemptive, I'll do the start minus the arrival. So 4 minus 4, that's a 0. You can also say the finish time, which is 9 minus the arrival time, which is 4, minus the burst, which is 5. This is also a 0. Okay. W2, that's waiting 2, which is the waiting for process 2. It finished at time 11. Here it is. And it arrived at time 6. Okay, 6. And the burst is 2. So this is going to be a 3. Okay. So I don't confuse you. Let me first do it with the first equation. The first equation says the start minus the arrival. Okay, so P2 started at time 9 and it arrived at time 6. So the waiting time here is 3. The finish time here is 11. And the arrival is 6 and the burst is 2, so this is also going to be a 3. For process 3, it started at time 11 and it arrived at time 10, so we have here a waiting of 1. You can also apply the other equation. So it finished at time 14, it arrived at time 10, it has a burst of 3, so also the waiting is 1. Of course, it has to give you the exact same result. P4, it started at time 15, it arrived at time 15, so the waiting here is 0. Let's apply the other equation. So P4, it finished at time 16, it arrived at time 15, the burst is 1, so the waiting time is 0. Now waiting 5, first equation, it started at time 20 and it arrived at time 20, so the waiting is 0. Let's apply the other equation. I finished at time 24, arrived at time 20 with a burst of 4, that would also be a 0. The W6, which is the waiting 6 here, finished at time 32, arrived at time, let me apply the first equation first. Now it started at time 30 and arrived at time 30, that would be a 0. It finished at time 32, arrived at time 30, and the burst is 2, that would be a 0. Of course, as you can see, it has to be exactly the same values. Now the average waiting time is going to be a 0 plus 3 plus 1 plus 0 plus 0 plus 0 divided by 6, which is going to be 4 divided by 6, which is going to be around 0.666%. Okay, or 66%. Again, the response time is going to be the same. You can also calculate the turnaround time, which is the finish minus the arrival. And then let's calculate the throughput. So the throughput, we have here 6 processes divided by the total time, which is 32. All right, and the CPU utilization is gonna be, let's calculate the bursts here. Sigma bursts is gonna be 5 plus 2 plus 3 plus 1 plus 4 plus 2. That would give you 10 and then 11, 17, which means that the CPU utilization is 17 divided by the total time, which is 32. I hope this is clear, and the next video I'm going to be solving shortest job first.